So, good morning, everyone. Thank you for coming. Welcome to Database Administration for the non-DBA. So, this is normally a 75-minute talk. Don't worry, I have not crammed 75 minutes worth of content into 20 minutes. I have actually pulled down just the kind of the top few things we want to talk about to really help keep those databases nice and healthy. So, before we start, where are my developers at? Few people, okay, DBAs. Couple, all right, sysadmins, most of the rest of you, management, the butt of all my jokes, 2, 3, 4 people, okay, cool. All right, I'll try not to make too much fun of you, I promise. So a little bit about me real fast. I'm the owner and principal consultant for Denny Cherry and Associates Consulting based out of beautiful San Diego, California. I've written a lot of books and you don't really care about the rest of that. So what I want to talk about today are backups. I want to talk about database maintenance. I want to talk about corruption. I want to talk about compatibility levels in SQL Server and what those actually mean, because there's a lot of misconceptions about that. And then we're going to talk about indexes. I'm going to talk really, really fast and try and get all this information out in just the 20 minutes that I've got available to me. So, when we talk about backups, what do we have to deal with? Well, we have 3 different kinds of backups that we're normally going to deal with. We have full backups, we have transaction logs backups, and we have differential backups. Now, these 3 different kinds of backups all serve their purpose in SQL Server, and they all serve it very well. The most important thing to remember is that for operational systems or production line of business systems, you are going to have to take both full and transaction log backups. Does anybody have something like a BlackBerry Enterprise server or some other type of server where we've got a really small database file and like a 500 gig transaction log file? The reason you have that is because you're not taking transaction log backups. For those of you who are older folks, been in IT for a while, you use BlackBerry Enterprise Server or you used to use it. That's why it was always this huge, huge server that did absolutely nothing interesting in your environment. Whenever we take our backups, the big thing about backups, no matter what kind of backups we have, is to always move those backups to another server or another machine or another data center in the environment. I cannot tell you how often I walk into an environment and they tell me, well, yeah, the database is on the E drive and the backups are on the E drive as well, but we're taking backups every day. Okay, great. So you're taking backups all the time. So that's great, that's fantastic. If somebody goes into your database and truncates the table or deletes data, no problem, we can restore it. What happens when that server catches fire? We've just lost all our databases and all our backups, so we can't bring anything back and get the system back online. What that means to a small or medium-sized business is congratulations, that company just closed. You just went out of business. So backing up these databases and being able to restore them is very, very important. If we're running a modern version of SQL Server, SQL 2014 and above, we've really got no excuse not to be moving these backups out of our data center. We can back up to URL and back up to the Azure environment very, very quickly and very, very easily, using the same commands that we're using today. Backup database to file. We simply change file to URL. We swap a couple of parameters out, and we can now back up to the cloud. And we can push backups directly from SQL Server to Azure using our network and push all our backups out where they actually belong to another data center. The beauty of Azure is you can actually set that backup storage account, which is what we're backing up to a read-accessible geolocated storage account. That means our backups are now stored not only in the data center we're backing up to, they're stored in another data center as well. So if, for example, I've got servers in my location in San Diego, and I'm backing up to US West, and US West has a catastrophic failure because there's an earthquake, odds are my office and my location is destroyed as well. My backups are now also in US East, so I can simply restore those backups from there to a VM or to another server somewhere on the East Coast and get back the information that I need. Very, very useful feature to have available to us. Backups can be taken through a variety of methods. It doesn't really matter how you take those backups as long as you're taking them. You can use maintenance plans. You can use your own custom scripts. There's lots of third-party scripts out there. Pretty much the gold standard in backup scripts was written by a gentleman in Europe named Ola Hanegren. And if you just Google Ola SQL, you'll get his maintenance scripts. And those you can just download, you run them, It'll create a few jobs for you. It'll create all the stored procs that you need, and then just schedule those jobs to run as frequently as you want to run them. It doesn't really matter how often you take backups. It just matters that you actually take them. Now, odds are nobody here should be determining how often backups are being taken on your environment. That's actually a decision that's going to be driven by the business. IT simply implements whatever their wish actually is. So if the business says we can only afford to lose 10 minutes worth of data, you should be running your transactional log backups every 10 minutes, because that will give you that 10 minutes worth of data loss that the business is okay with. If the business is okay with losing a couple of hours worth of data, then you can run those backups every couple of hours. But that's the decision the business has to make, because the business is ultimately responsible for how much data is lost and how many customers they need to figure out they're screwing over in the event of data loss. So when it comes to restoring data, obviously that is going to require backups. And this is my primary responsibility. My first job as a DBA is to be able to restore the data. If I can make the data faster in the process, or while I'm not restoring data, so be it. But I get paid every day to come in and do nothing. If I can't restore this data, there's no reason for me to be there. I have to be able to actually restore that. So when restoring databases, the first thing we always have to restore is that full database backup. If I can't restore the full database backup, I have to go back to an older one. So I need to keep a couple of those full backups around all the time in the event that I can't restore that full. I never trust a backup is successful, even if SQL Server says it was successful. I always want to be able to restore that backup in order to prove that that backup is good, because a backup is useless until it's been restored and proven that it can actually bring back that data. So once I do that full restore from that full backup, then I've got some options available to me. If I've taken that differential backup, I can then do a differential restore, and that'll get me up to whatever that differential is. The nice thing about the differential backup is it's a backup from the last full backup to current. So if I only take weekly full backups, I only need to restore my most recent differential, and then I can throw my transactional log backups on top of that and get up to whatever the point in time is that I want to actually restore to. Now, one of the reasons we take backups is to deal with corruption. So one of the really cool things that was introduced in SQL, I want to say 2008, give or take, was the page level backup, or page level restore. What this lets me be able to do is, if a database is corrupt, instead of restoring an entire database, I can restore just that 8K page that's corrupt. Because when we deal with corruption, we're dealing with it at a very small level. 8K, 16K, 24K, somewhere around that range is going to be what's corrupt. So if I've got a 2 terabyte database, I really don't want to wait for 2 terabytes of data to be rewritten to the hard drive and my customers to be down for that amount of time. So instead, I'll restore the 16 kilobytes that's actually corrupt, roll those forward using the page level restore, and then get the database back online probably within a few minutes instead of a couple of hours while I'm restoring everything. Now, a few of you are sysadmins and you like doing this thing called snapshot backups with some of the vendors that are here in the exhibit hall. As a DBA, we're going to have a discussion about that. And it's not going to be a pleasant one for you, because I'm not going to like those backups. I can't roll those transaction logs forward on backups that are taken when we snapshot VMs. I can't do page level restore. And most importantly, I can't pick the time that I'm restoring to. So one of the cool things in SQL Server that I can do is we have a different version of the phrase point in time than sysadmins do. A sysadmin is going to say a point in time is whatever time I take my snapshots. If I take my snapshots every hour, that's the point in time that I can restore to, which is cool for like everything but databases. On a database server, my version of point in time is whatever millisecond I decide, and I have to be able to make that decision after the backup has been taken. So when I'm doing my transaction log restores, I can roll that transaction log forward or backward to whatever point in time I want, and then I can stop that restore process at that specific moment in time. I can even roll a transaction log forward and stop at a specific transaction if I know the name or the ID of the transaction. So we've got a lot of flexibility if I do my native backups that I lose if I do some sort of snapshot-based backup through VMware or through Hyper-V. On top of all these options, I have another backup option available to me. That's the file group backups. You're going to use that in your data center environment where you're backing up just a piece of the database, and that's a lot longer conversation than we have for today, so I'm just going to pretend that bullet point didn't exist. So within our database maintenance, or within our databases, we need to do some sort of database maintenance. That's because our databases need a little bit of tender love and care, just like everything else in IT. We have to maintain everything else. We have to maintain our switches, we have to maintain Windows, we have to maintain SQL. We have to maintain those databases as well. So we do that through our database maintenance plans. So we can do one of two things. We can do an index rebuild or an index reorg, also called an index defrag. It doesn't matter which one of these we're doing, as long as we're doing one of them. Now, if we're doing index defrag, we also need to update statistics as well. Now, I'll tell you why. The reason we need to do this is because an index rebuild and an index defrag are basically the same thing with one major difference. When we're doing an index rebuild, we are basically dropping the old index and creating a new one and sliding it in place. So SQL Server is doing all this in the background for us. Now, an index rebuild can either be an online or an offline operation, depending on what version and what edition of SQL Server you have. Every time they release a new version of SQL, more and more things can be done online. The downside of all this is an online operation is going to require Enterprise Edition. So break out those checkbooks. We're going to be buying, expensive licenses. I know a lot of things rolled down into Standard Edition in SQL Server 2016 Service Pack 1. This is one of the things that I'm guessing will probably never make its way to Standard Edition, because this is probably the driving factor for buying Enterprise Edition, is the fact that we can rebuild our indexes online. Because we're creating a new object and sliding it in place in the background, we're getting updated statistics on those index rebuilds while they're being done. The upside to index defrags or index reorgs is they're always an online operation. Now, what I mean by an online operation is users can continue to use the database tables while my operation is happening. So if I'm running an index defrag, my users are not impacted. If I'm running an index reorg on Standard Edition, my customers are going to be impacted, because when I'm running an offline operation, that simply means users are being blocked and cannot access the tables. So they can't insert new rows, they can't pull down rows from the table using select statements, those sorts of things. When we're dealing with an index defrag, it's moving row by row information. So it's looking at all the rows in the table and figuring out what needs to be moved around. So if we only have a very small amount of fragmentation on our tables, this is probably going to be the more efficient operation for us to run. If we need to move a lot of rows, this is going to be a less efficient operation, and we're going to need to look at the index rebuild. Now, there's lots of scripts out there to do this, or you can roll your own scripts that will actually do this for you, because SQL Server will tell you what all these different fragmentation levels are. The easiest way to figure this out is to go download all the Hannigan scripts and run them, or run maintenance plans, and that will help figure a lot of this out for you. The cool thing about the index defrag, again, is that it only moves those rows that actually have to be moved, whereas the index rebuild is going to move all the rows. The cutoff is usually about 30%. When you're less than 30% fragmented, an index defrag is going to be your best bet. If you're more than 30% fragmented, an index rebuild is going to be your best bet. Now that varies. It isn't always 30%, but that's a good cutoff point for most systems. Now, let's talk about corruption in SQL Server. This is probably the nasty part of this conversation. All databases can and will become corrupt at some point. When a database becomes corrupt, it goes into suspect mode usually, and you can't access it. And more importantly, the users can't access it, and whatever the users were doing stops. So if that's a system that makes the company money, you've just stopped making money until you figure this out. So that's obviously going to be a problem. Corruption is usually a hardware problem. I've shown this slide to my friends at EMC and at a few other storage vendors at HP and stuff like that. And the engineers all agree with this slide. The marketing people don't, but I don't really care what the marketing people think very much because they're marketing people. Don't tell my marketing person I said that. Corruption should be checked for regularly to make sure that there is no problem with your database. How often do we want to check for corruption? As often as we can get away with. If we have to, I want to check for corruption, say daily, but I want to keep 2 backups just in case there's a problem. So I want to check for corruption half as often as I run my full backups. So if I run full backups weekly, I want to check for corruption at least every week, and I want to keep at least 2 weeks worth of backups in case there was corruption and my full backup that I just took is corrupt. I need to be able to go back to the previous one that I know is good and be able to restore it. We can see how corruption and backups are going to start going hand in hand real fast all of a sudden. Depending on what's corrupt, I may be able to repair the database without any data loss. So if my non-clustered indexes are corrupt, I can fix the problem without losing data. If the actual tables are what's corrupt, then I'm going to lose some sort of data. Now, when you run the command dbcc check db, it's going to tell you what repair level you have to use to fix a database that's corrupt. One of those flags that it's going to tell you is going to be called allow data loss. When it says it has to use the allow data loss flag, you're going to lose data. That flag was named that way for a very specific reason. So corruption is going to happen at some point. It's just a matter of how we deal with that corruption. That's going to determine how well we can recover from it and how well we can move forward and if we can keep the system alive or if the system is going to die when this happens. Some corruption that's going to happen to your database at some point is going to be unrepairable. This is going to happen to system objects. If a system table becomes corrupt, there's nothing SQL Server can do to repair it. Your only option is to run a restore. This is going to be one of the tables that contains the metadata about your tables. Obviously, if these become corrupt, all the rest of the data inside the database is useless. Now, the good news is SQL Server only writes to these tables or these pages when you're creating new objects. So the odds of you actually having a corruption problem inside one of these tables is very, very small. But if it does happen, you're going to have some big problems. The good news is you're probably already in a maintenance window and can deal with it fairly easily. So let's talk about compatibility level. Compatibility level is going to be what tells SQL Server what version of the language to support inside that version of SQL Server. It does not affect the version of SQL Server that you can actually restore your databases to. So if I've got a SQL 2017 server and I've got it set in SQL Server 2012 compatibility mode, I cannot restore it to SQL Server 2012. I can only restore it to another SQL Server 2017 server. What I am doing is I'm running the SQL Server 2012 version of T-SQL on that database or inside that database. So if I run a command that has certain kinds of parameters or certain kinds of SQL, it'll act just like SQL Server 2012. Now, SQL Server is going to support several versions of compatibility level when you look at various versions of SQL. We're always going to support at least 3 versions down, if not further. So SQL Server 2014 through 17 are going to support compatibility level 2008 and up, for an example. Now, a perfect example of why this matters is if you're running in the 2008 compatibility level and use a function as an input parameter's value, you'll get an error message. It won't work. If you switch that compatibility level from 2008 to 2012, it will work. Because now that's a supported operation, it's a supported command. So last thing I want to talk about, indexes. So indexes are your go faster button in SQL Server that we've always been looking for. And that's because they're going to speed up queries and make queries faster as we're working in SQL Server and working on our databases. The way these make things faster is by wasting space. We're duplicating data. The reason we're duplicating data is because we're resorting that data as we're writing those indexes to the SQL Server and to the hard drive. So we are making this trade-off. Do we need to spend 100 gigs of data to make the database faster? Potentially. It may make sense, it may not. That's one of the things we need to look at in the database and figure out. And we figure that out usually by trial and error. We create the index, do things get faster? No. All right, drop the index, it's not doing anything for us. Once we've done this enough, we can look at the execution plans that SQL Server spits out, and we can look at the missing indexes in SQL Server and figure out what databases we need to look at and what indexes SQL Server wants created. So like I said, we are trading space for speed. We make the database bigger, this makes the database faster. I have lots of customers that complain to me the fact that we need to make the database bigger in order to make it faster. And the answer to that question is simply yes. The goal of this is to make the database bigger because that is simply how we get things faster in the database. Now, there are a few different kinds of indexes available to us. Most of the index shooting you're going to be doing is going to be on non-clustered indexes. That's like 99% of index work right there. There are some cases where you want to look at column store indexes, which were introduced in SQL Server 2012 and just got better over time and rewritten a couple of times on top of that. So there are some better options available for some use cases. For some use cases, things like column store aren't going to make things faster. So a lot of that just depends. So unfortunately, I am all out of time. So I am literally right on the other side of this wall for the rest of the day, except for when I'm presenting later today. Don't forget to do your evals for the various presentations you see throughout the day. If you want to grab a business card, feel free. I've got some up here. Thank you all very much for coming. I do appreciate it.